Hello and welcome to the introduction of our tutorial on Constraint Programming for Robotics. My name is Raphael Voges and I am co-organizing this tutorial with my colleagues Simon Rohu, Luc Jolin and Benoit Desrochers for the International Conference on Intelligent Robots and Systems, IROS 2020. First, let me give an introduction to constraint programming. Here, our goal is to estimate the state of a mobile robot given a set of constraints or rules coming, for example, from state equations or measurements. Additionally, we need an initial estimation of the solution, so we need an initial solution set, but this initial solution set can be infinitely large. Then the idea is to let a solver perform the estimation by adhering to our constraints. So given the set of constraints and the initial estimation of the solution, we aim to remove inconsistent parts of the solution until we arrive at a fixed point and can no longer remove parts of the solution space. So here, starting from this initial yellow solution set and here the true solution X star, we remove inconsistent parts of the solution set until we arrive at a much smaller solution set. But the important thing is this smaller solution set still is guaranteed to contain the true solution, and so we are able to approximate the true solution without saying where the true solution is in this set. This tutorial is organized as a basically programming tutorial that stands on the TubMOOC library. So we introduce the TubMOOC library. For this, we require you to have an initial basic knowledge of Python or C++. You can choose because the exercises are available in both languages. And speaking of exercises, we prepared 4 weeks of exercises starting from October 26. But there is also a 5th week, which you have to complete before the actual tutorial starts, which is week 0, and this is basically just the installation of the library. If you complete all exercises, it is possible to obtain a diploma, so this might be interesting for some PhD students that need these ECTS credit points. And during the exercises, we offer interactive meeting sessions every Tuesday afternoon at 2 p.m. starting from October 27th. Moreover, we also will provide a Slack channel which can be used for easy communication in between. This will be announced on the website. Speaking of the website, this is the main platform for our tutorial, and all information, so the content, explanation, everything will be available on the tutorial website, which you can see here. And this website also introduces the exercises and provides a link to upload the exercises to make it possible that we check them and allow you to obtain your diploma. Now I want to quickly introduce the content of our tutorial. So I already talked about week 0. It's basically that we introduce the concepts of constraint programming and interval analysis. You will install the TubMOOC library and you will run some first Hello World program to ensure that the installation worked and everything will be done or will be ready for the first week, in which you will start working with intervals and contractor. So the first lesson is just an introduction to intervals, like computing with intervals, addition, multiplication, and so on. And also an introduction to contractors, so these operators to remove inconsistent parts of the solution space. The second part of the first week is a static range-only localization. So we don't know where our robot is. We know the position of these landmarks and we know the distances to these landmarks. So we know that the robot must be in the intersection of these 3 circles, but since we have some uncertainty on the distance measurements, we can only compute the robot's position also with some uncertainty. And in this case, of course, the constraints are the range-only data from the landmarks. In the second week, we now additionally know the bearing data, so not only range but also bearing, and this makes it necessary to decompose the problem into basically 2 problems which will then be merged again. So we have the problem of range-only localization, bearing-only localization, and we combine this after decomposing the problem initially. In lesson D, you will build your own contractor to solve the landmark association problem. So we no longer know, or we can no longer identify the landmarks. We only know that it is a landmark, but we don't know which one. So we have to solve the association problem. For this, you will develop your own contractor. In the third week, we move from this static context. So previously we did assume that the robot does not move. Now the robot is allowed to move, and so we have to also deal with the uncertainty during movement. So here in this blue tube, you can see the white trajectory, and the tube is basically an enclosure of the true trajectory, but with some uncertainty, since we have some uncertainty in the state equations. Afterwards, after introducing the tubes, we now localize with asynchronous measurements. So before we had this range-only data, everything at the same time, and we were all able to solve our localization problem. But now, while we move along our trajectory here, we get data from the landmarks and want to use this data to improve the positioning of our robot. And since we don't have everything at the same time, we have to do this asynchronously. Finally, in the fourth week, we will now do a dynamic localization with data association. So previously we already built our own contractor for the data association problem, and now we combine this with the concept of tubes and dynamic localization. So as it says here, this is an extension of lesson D, which was building your own contractor to a dynamical context. Finally, we put everything we have so far together to solve a range-only SLAM problem. So now we no longer know the position of landmarks, so we have to insert them into our own map once we see them, and if we see them later again, we can use them to improve our positioning. So this is a classic SLAM problem, and for this we will apply all learned concepts of constraints and interval analysis. Finally, if you want to do something extra, we also provide some explanations for an online SLAM algorithm, so doing this online while moving on a real robot. We hope this introduction convinced you to attend our tutorial, and we would be happy to welcome you there. Thank you.